Hey, welcome back. So here we are, we're in the month of May, and we've finally got rid of those triangles after 3 months, and we get to do circles. Now, in these circles, the other day, we got our toilet paper roll, we worked around the distance around, the circumference, okay? Now, we have a note sheet, and we're ready to get started. We went out with the old, in with the new. I want to show you the video so that you see the real world math and what we're trying to accomplish here as we get started with our new vocabulary. Okay, so we're just going to click on this little video guy here, click, and we're going to watch this video of the Great Seattle Wheel again. Monty here. I just bought my $13 ticket for the Great Seattle Wheel. Your job is to model my motion as I go around the Great Seattle Wheel 3 revolutions in 15 minutes. Remember, the diameter of that Ferris wheel is 175 feet. Graphically represent my motion as I go around the wheel 3 times, and then at the end, state how far I actually traveled. Good. Okay. So now we have this 150 feet.
This brilliant monocular telescope is taking the world by storm.
Crazy. Okay, 150 feet. The Ferris wheel is 50 meters tall. We're going to do 150 feet across. Okay. All right. So the first thing we need to do is answer question 1. Okay. This is the Seattle wheel. We can answer according to this here, 50 meters tall, 50 meters. So 50, so the diameter of this one is 50. The radius would be 25. Okay? 25. So the very first question, determine the length of the steel arc connecting one passenger car to another passenger car. The steel arc connecting. Oh, we need this. Holy smokes. How are we going to do that, Mr. Miller? All right. So the first thing we need is R. Okay? R is 25. Boom. Boom. 25. Okay. Now, everybody, count how many spokes on this wheel. Everybody count, okay? 1, 2, 3, 4, 5, 6. Okay, hopefully, pause the video. Hopefully you all got the same thing. 18 spokes. All right? So off to the side, we're going to write some notes here. 18 spokes. Now, 1, 2. We need to find this angle measure. Angle, 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 angle. We need to find the angle between every spoke. So do a quick share around the class. How can we calculate that? Angle measure. How do we do that angle measure? Okay, pause, have a discussion, come on back. Okay, all circles are 360 degrees. Well, these are evenly spaced. So 360 divided by 18 is going to be 20 degrees. So 20 degrees. Okay? This is lesson number 1 of circles. This 20 degrees. Everybody. 20 degrees. I want everybody to write this next piece down. Okay? Each piece of pie, each piece of pie is 20 of the 360. Okay? Every piece of pie, every piece of pie is 20 degrees over 360 degrees. Okay, everybody write that. 20 degrees of 360 degrees. The secret to success the next 3 weeks is to understand this concept. Okay? Mathematically, 20 of the 360, okay, is a ratio. It is. There's 18 pieces. How do you describe these 18 pieces? 20 over 360. And if you use your calculator, you guys remember we have that fancy calculator? Grab your fancy calculator right now. Get on and go 20 divided by 360. And we get this ugly decimal. Remember that there's a math button. Click. Convert to fraction. Enter, enter. 1 of 18. One piece of 18 pieces. And we counted 18 spokes. Isn't that exciting? All right. Now that we know that, that's lesson number 1. The percent of the total, 20 of the 360. All right. Now, our next goal is to calculate this length. Well, number 5, circumference. The circumference of this Ferris wheel, C, is 2 times pi times r. Remember our formula sheet? So the other day when we were in class, you got a formula sheet. Go back to your formula sheet. Central angle. The central angle is 20 degrees. The arc length, we're calculating it, is 2 times pi times r. 2 times pi times r. So we get 2 times, this one was 25 meters times pi, which is 50 pies. Grab our fancy calculator, and we have 50 times pi. See the pi button right there? Second pi equals 157.08 meters. Okay, we're not done. We just calculated the circumference. The circumference is the entire distance around. C equals 157.08. We need this arc length. So now everybody, new vocabulary. Arc length is the distance of a piece of the circumference. Okay? Now, here's the math piece. Okay? we need to know the edge of our piece of pie. How much is this piece of the pie? How many pieces of pie did we make? Have a discussion. How many pieces of pie are there? Mm. 18 pieces of pie. Divide by the number of pieces of pie. Or, so our arc length equals the circumference times 20 over the whole 360. Okay, here's the learning for the week. We need you to understand that 20 degrees 18 times, or a percent of the whole, 20 of the 360. Okay, so the final answer is 157 multiplied by the angle measure, this piece of the whole. Isn't that cool? So just grab your calculator. 157.08 times 20 divided by 360. And we get some goofy number. 8.726, 8.73, 8.73. Now, degrees over degrees, degrees cancel. We have our meters, 8.73. Okay? Meters. That's it. There's a lot here. We're 12 minutes into this video. This may be all we get, but here's the learning. We want you to understand arc length is a piece of the circumference, and we know how to calculate the distance around any circle. But we need you to understand how to find the piece we're looking for. 20 of the whole 360 in this case. For those of you that get it and you understand, hey, I could have just divided by 18, that's good. Awesome. But not everybody's going to get to that point. But as long as you know 20 of the 360. All right? So again, pause the video. Here is the actual assignment for the week. The we do, you do. Okay, so on your sheet, calculate. The measure of AB is 40 degrees. We want the length of each arc compared to the circumference. Arc length, the measure of AB. All right. Now, if we have 40 degrees, the answer is 40 degrees of the 360. Everybody, just write 40 of the 360. That's what we're looking for. Now, model it. Model it. Got our Ferris wheel. We have this circle. 360 degrees all the way around. 40, somewhere in here, right? If this is 0, 90, 180, 360, then 40, this should be 45, somewhere in here. 40 of the 360. That's what we're looking for. This piece right here. The ratio of the length of the circle's circumference. So we have the whole piece. We want 40 of the 360. Okay? Go down to the next one. The measure is 105. Okay? Again, I'm going to sketch it first. 105. 90 is here. So 105 would be what? Somewhere around here. Okay? So we need this arc. That arc. 105 degrees. So the answer to the problem is just 105 of the total. Okay? And this tells you how many pieces of pie you would have, right? We'd have, what, 9 slices, right? Wouldn't there be 9 slices here? This would be 315, 3 1/3 pieces. It wouldn't be an even number, right? Okay, all right. So again, pause the video if you need to. Now, what if we actually put numbers to this? Okay, so we're going to draw a circle. And we need 45 degrees. We know that it goes 0, 90. So 45 would be halfway. We're interested in this piece. And in this case, they told us 12 meters is the R. 12. So here's an actual math problem. The total circumference is 2 times pi times r, 2 times pi times 12, 24 pi. What's 24 times pi? 24 times 3. 24 times pi. 75.4. 75.4. 75.40 meters is the total. That's the total circumference. We only want the red piece, which is 45 of the total. How many 45s are there? So, this arc length is the circumference times the piece of the whole. Okay, again, go to your cheat sheet if you missed class. Arc length is the circumference and the piece of the whole. The circumference and the piece of the whole. Okay, so in our case, we have 75.4 times 45 of the 360. Grab our calculator. 75.4 times 45. Divide by 360. Voila. 9.42. 9.42 meters is the answer. Right there. That red is 9.42. And if we did that all the way around, we'd get the grand total of 75.4. Cool? Okay. All right. Now, there's one more to practice. Okay, you can do that as a class. And then you go try them on your own. That's our assignment for the week. Okay? Now, there's 4 total problems. We had 2, and then there's a couple more, and then there's a couple more. Okay? So, we just have our practice to do, and you've been introduced to circles and real-world math all in 1 week. Have a great week. What's that? Okay. Now here's the challenge. Okay? Mathia. I'm going to come back and talk to you about this Mathia page in another video. See you in a minute.